In this video, I'm going to be talking about half-life and doing a few example problems. Half-life is the amount of time it takes for half of a radioactive substance to decay. The half-life formula is the final amount of a radioactive substance equals the initial amount of that substance times 1/2 raised to the time divided by the substance half-life. Let's look at a few problems. Alright. A certain isotope has a half-life of 6 hours. How much of a 5-gram sample will be left after 24 hours? So you're looking for your final amount. So you know your initial amount is 5 grams. Your half-life is 6 hours, and the total time is 24 hours, the time that elapses. Okay, so 24 divided by 6 is 4, right? So this is what you get. And go ahead and put that on your calculator. 5 times. And that equals 0.3125 grams. Okay. Let's look at a harder one. Carbon-14 has a half-life of 5,730 years. How long will it take for a 2.7 gram sample to be reduced to 0.0844 grams? Okay. So you know your final amount is 0.0844 grams. Your initial amount is 2.7 grams. You're looking for T, and your half-life is 5,730 years. So first let's divide 0.0844 by 2.7. So that is 0.0313. Okay. Now at this point, what I would recommend is using natural logs. I don't know if your chemistry teacher will go ahead and teach you how to use natural logs, but that's the way I'm going to do it. It's really simple. Even if you don't know what the natural log is, or you don't know anything about logarithms, it really helps for these type of problems. So what you're going to do here is you're going to take the natural log of both sides. So okay. Then what happens is that the exponent that 1/2 is raised to will become the coefficient. So what that means is you take this and you put it in the front of the natural log. Alright, then you can divide this by this. So divide both sides by the natural log of 1/2. And then where's this on the TI-84? Let me show you. If you look here, the natural log button is right here. So I'm going to go ahead and type that in, the natural log of 0.0313 divided by the natural log of 1/2. So that's giving me 5. 5 equals t over 5,730 years. I can multiply by 530 years on both sides. This cancels with that. So t equals I think 28650 years. Yeah, so t equals 28,650 years. Alright, even if you've never used natural logs before, this really helps, so go ahead and just understand. You take the natural log, then whatever your exponent is brought to the front, and then you're just left with the natural log of 1/2. You take the natural log of the other side too, then you divide by the natural logs, and then you can just find t for itself. Okay. Now, in this example, we found t. In the next example, we will be looking for the actual half-life, and we'll be given t. So let's look at this example. So a sample of a radioisotope is found to have decreased from 11 grams to 0.0859 grams in 1.23 minutes. Calculate the half-life. So our final amount is 0.0859 grams. Our initial amount is 11 grams. We're looking for the half-life. And our time is 1.23 minutes. So first I'm going to divide this, both sides by 11 grams. So that's going to get me 0.00781. And here. Now I'm going to take the natural log of both sides. Alright, then the exponent becomes a coefficient, so okay, and then I'm going to divide both sides by the natural log of 1/2. That's going to get me 0.00781. side, this is gonna get me 7. And then I can multiply both sides by h. This cancels with this. Then I can divide both sides by 7. Actually, wait. 7h equals 1.23 minutes. Okay, finally divide both sides by 7, and your half-life is 0.17